All right, you guys, trying out this making my own video. It's been quite a journey. I've learned a lot and found out I don't know a lot, so hey, there we are. I want to start with so the lesson's going to be about adding and subtracting rational expressions. And to start with, we're going to start with common denominators and just kind of learn, some of the simplifying pieces, just some of the parts of this process. And I want to start with an example of when we have common denominators and we added fractions. Well, the deal was we had to have common denominators, and in this case we do, thank goodness, because that's going to make our lives easier. And when we had common denominators, the thing that we did is we brought the denominator over and we wrote it once, okay? And we combined the numerators. And we got something like 4 over 2, which in this case can be simplified. We can simplify this, and that equals 2 because 4 divided by 2 is 2. So again, the process. One denominator, combine the numerators, simplify your answer if you can. There's your answer. Okay. So, oh, and by the way, if you're just watching me do this, probably this first example, you didn't probably need to write anything. But again, videos, if you're not involved with them, are not extremely helpful if you're not taking notes. That's not how we do class. We take notes when we're in class. So write this second example down. So you can pause it, write it down, and then let's kind of jump in with this. All right, again, good news. We have common denominators. We're eventually going to have to build up and create common denominators, but we've got them. We're adding. So here's the process. We're going to put them together over one denominator, and we're going to combine the numerators. So this is x plus 2 plus x plus 3. I have common terms, common terms. So these are common terms and these are common terms, so we can combine common terms. So I get 2x plus 5 over 3. So that's what we did up here. We combined them and then we looked to see if we could simplify them. Now when I look at this to simplify, the thing I want you to start to see is what we have in this numerator. I call this, we have ourselves a family. I call this a family. You don't break up families. It's just a way to remember it. But I have an expression up here. These are connected by that addition. So I put parentheses around them just so my mind sees that's one thing. So unless I could factor something out, then I could cancel it with a 3. Or if these two were the same, I could cancel. But they're not. This is simplified. This is my final answer. And I'm going to add on to that with the other examples that I do. Just kind of thinking about the simplifying is probably the toughest part. Okay, let's do another example. And again, hit pause, write it down with me, do the problem with me. It's the best way to go here. Okay? So question number 3. All right. Let's go through the process. So the process is we write the denominator once, 2x, we just bring it over. We add the numerators, this plus this. So I'm not going to write it out the long way. So I've got common terms of x and x. So I would have 2x plus 5. You might have written it as 5 plus 2x. Those are the same. Addition is commutative. And I know what some of you are going to want to do right here, and this is probably the most common mistake, is people will go, she said something about you can cancel stuff, so I'm going to cancel this 2x with this 2x, and my answer is just going to be 5. No. I want to remind you, this is a family. So I keep it in parentheses to kind of tell my brain that unless I can pull something out of this family, nothing cancels. So if I look at that numerator and say, are there any common factors? Is there anything I can factor out of here? And the answer is no. Because the answer is no, this is my answer. In the next example, I think, in the next couple of examples, there's going to be some simplifying we're going to do. But I call this canceling in pieces, and you will never get it right if you do that. Okay? Let me show you an example where we could cancel something. Example 4. Go ahead and write this down. Okay, so I have a common denominator of 2x squared. So I'm going to write 2x squared in my denominator. And I'm going to combine the numerators. I get 2x plus 12 in my numerator. And I'm going to remind myself right now, this is a family. You cannot cancel anything when it is within a family. But when I look at this numerator and I see that, oh, there's a common factor of 2 here that I could factor out. So wouldn't this be equivalent to 2 times the expression x plus 6 over 2x squared? So again, take a second and look at both of these. Can we agree that these two things are the same? This is just a rewriting of this. Now, because I have something outside of the family, I can cancel it with that too. So now my final answer here is going to be x plus 6 over x squared. All right, so again, I want you to look at, we could cancel here, but I couldn't cancel here because I couldn't break anything out of the family. If I can't move anything outside of the family, I can't cancel it. All right, what changes when we go to subtraction? All right, go ahead, write this question down for me. Hit pause if you need. So with subtraction, here's the change that we need to make. So what I always do, I want to just remind you that subtraction always meant add the opposite. I think it was Mrs. Carey at Northeast that used to say it was chum chum. So if you had Mrs. Carey, you probably remember that. So what I do with this problem to start is I go ahead and I change any subtraction into an addition. And then I put parentheses around that family up here, and I remind myself to distribute that negative through everything that follows. So that's going to make this a negative 2x and this a negative 5. It's going to change the sign of everything that follows. So now look at my problem. I'm just like the other 4 examples that I did, where I'm going to write my denominator, 5x squared. I'm going to combine terms of the numerator. So this is negative 2x and x is negative 1x. If you put the 1 there, you're fine. Probably on Delta Math, you don't want to have that when you go to answer your question. And then a positive 4 and a negative 5 is negative 1. And when I look at this and this, I'm going to remind you, this is a family. I just go ahead and I always kind of visually put that in there. If I can factor something out here, I can cancel. But these two, I guess they have a common factor of a negative 1, but that isn't going to help me down here. It's not going to help me cancel anything. So I would probably leave my answer that way. All right. I want you to try this next example. I think. Yes, I want you. I thought I had it written on there. I want you to try this next example. So go ahead, hit pause, write down what you think your answer is, and then when you're done, go ahead and compare it with mine. All right. So what I do is I remind myself this is a family, and for subtraction, I'm going to add the opposites. So I'm going to change that to a negative 4x and this to a positive 5. I'm then going to combine like terms in the numerator and leave that 4x in the denominator. So 2x plus negative 4x is negative 2x. And 3 plus 5 is a positive 8. Okay. So right now, I see that I have a family right here. So right now, I can't cancel anything. But if there was a common factor in this numerator, I should probably try to factor it out and see if it cancels someplace else. So if I factor a negative 2, some of you will factor out a positive 2. It's okay, we're going to get the same answer. I always try to leave this to be a positive coefficient if I can. So this is negative 2 times x minus 4 over 4x. Now take a second and look at this. If I multiply negative 2 times x, I get negative 2x. If I multiply negative 2 times negative 4, I get positive 8. And I'm going to write that over one common denominator. So I just rewrote it. That's all that's happening here. Why did I do that? Because I can cancel. I can divide 2 by 2, and I can divide 4 by 2. And my answer is negative 1 times x minus 4 over 2x. Okay, hopefully this helps you for Delta Math. We'll kind of see, and I like your feedback in terms of whether this is better than the Khan videos. Probably what Khan would have said that's just a little bit different. He talked a little bit about the domain and what x could not be equal to. Remembering that x cannot, we can't have zero denominators here. So the one value of x that would make a zero denominator would be a 0. 4 times 0 is 0. So we would say x cannot be equal to 0. There's none of that discussion on Delta Math. Hopefully this helps.